So today we are continuing on with section 2. So in the homework it'll say P2B for the homework assignment, but I'm going to be breaking up this P2B actually into 2 days worth of notes. Today what we're going to focus on are the negative exponents. Now, when you have an expression, an exponential expression that has a negative exponent, it doesn't make the number negative. It actually turns it into a fraction. A lot of students think, oh, they see a negative exponent and they think reciprocal. So when you're doing the homework tonight and on the quiz and on the test, if it ever asks you to simplify, your goal here is to simplify everything possible and leave all your exponents positive. So for example, if you want to think about these negative exponents like reciprocals, for example, if I take this first expression, a raised to the negative n exponent, I can turn something that's not a fraction into a fraction by adding a 1. And then to evaluate or simplify this and to make that exponent positive, I'm going to flip this fraction to its reciprocal. So I'm flipping it upside down. I move that a to the negative n power to the bottom of the fraction. So it never makes the answer negative, it turns it into a fraction. Now, if it's already a fraction like this, with the exponent being negative in the bottom, to make that exponent become positive, again, I'm just flipping it to the reciprocal. I move the denominator to the numerator to the denominator, and again, anytime there's a 1 in the denominator, it just simplifies to your numerator. So for some students, it helps them to think about, I'm just flipping it to the reciprocal. The other rule that we're going to be using in the notes today is when you divide exponential expressions, and if they have the same base, we are going to take those exponents and subtract them. So if you notice here, they both have the base of a, and then we just take their powers, the m and the n, and we're subtracting them. But let's go ahead and try some of these without just letters, with some numbers. So for example, let's say I have 5 raised to an exponent of negative 2. Now that negative 2 exponent does not make this negative. Remember, we're thinking reciprocal here, so if it helps you to put a 1 there, and then flip it upside down, and now make that exponent positive. And then you will have to evaluate what 5 to the second power is, and that becomes 1 over 25. Now let's say it's already negative in the denominator. So let's say we have 1 over 5 to the negative 2 power. Again, think reciprocal to make it positive. And then you'll evaluate 5 squared. And then whenever there's a 1 in the bottom, 25 divided by 1 is just 25. Now let's try applying that division rule. So let's say we have 2 to the 7th divided by 2 to the 5th. Notice both of my bases are 2, so all I have to do is keep the 2 and then take those exponents and subtract them, becomes 2 squared, and I get 4. The same thing's going to happen if it were flipped. Let's say it was instead 2 to the 5th over 2 to the 7th. Bases are still the same. The only difference, when you subtract and get a negative exponent, we need to make that positive. So again, if you think reciprocal, flip it, and then it becomes 1/4. Okay, so for the next one, again, remember, a negative exponent does not make it negative. It makes it a fraction. So again, if it helps you to add a 1 to the denominator and then flip it and make that exponent positive, and then now we evaluate 4 squared, and we get 1/16. Same thing on number 2. I could add a 1 to this, flip it, and then make the power positive. And we're done. Now for the next one, that -4 is only on the x. It's not on the 2. So the only thing that I'm moving is the variable x. The 2 is going to stay in the numerator, and then the x to the -4 moves to the bottom of the fraction. If this question would have been 2x in a parentheses and then raise that whole quantity to the -4, then the whole thing would have moved to the bottom. But because there was no parentheses, that -4 exponent was only on the x. And then here you would have to take this a step further and actually do 2 to the 4th power, which is 16, x to the 4th, with a 1 on top. 3, this -4 is only on the x. It's not on the 2. So the only thing that I have to adjust is the part of the problem that has the negative exponent. So the only thing that has the -4 is the x, and to make that x to the 4th positive, it's got to move to the bottom of a fraction. Now, when it's a fraction, this is where reciprocal pays off. All I have to do on number 4 is flip the fraction and then make the exponent positive. And now I do have to figure out what 5/2 to the 3rd power is. Now you can do this 2 ways. You could either say, I'm going to do 5/2 times 5/2 times 5/2, or you could say, I know that power of 3 needs to go on both the 5 and the 2. Either way, you're multiplying 5, 5, 5, 125, and then 2 times 2 times 2, and get 8. I'm okay with you leaving it improper. You don't need to make it a decimal or a mixed number. Also remember, for that very first, we're not using calculators for like the first couple months. So no calculators at all. So you would have to actually multiply 5 times 5 by hand. 5 times 5, 25. Whenever I get 25s, I think about quarters. 5 quarters is $1.25, so 125. The next one, notice that -4, the whole thing is in a parentheses. So I'm going to take that whole thing and move it. If you want to think again of this as being underneath a 1, flip it, make the power positive, and then -4 times -4 is positive 16, and it's 1/16. Now, the next problem looks like it's the same, but notice there's no parentheses. So if you'd rather think of this as being the -2 is only on the 4. So if you want to think of this as being a -1 times 4 to the -2, then the -1 stays in the top of the fraction, and then the 4 to the -2 moves to the bottom. Then make it 4 times 4, and you get 16 over, and then -1 on the top. Keep in mind that that answer, or if you move the negative sign to the front, or if the negative was in the bottom, all 3 of these mean the same thing. If there was a negative in the numerator and the denominator, then it would simplify to a positive answer. All right, number 7, same scenario here where this -3 exponent is only on the y. The x is going to stay in the numerator. So I'll leave the x in the top. The only thing I need to move to the denominator is the part of the term that has the negative power on it. So that's just your final answer, x over y to the third. Number 8, we're going to use our division rule where we're going to subtract the exponents. Now, for the 4/16, I need to simplify this fraction part of it. So I need to take these coefficients here, and I need to reduce 4/16, and this actually simplifies to 1/4. So far I have 1 over 4 for the coefficients, but then for the x's now, I'm going to take those exponents and subtract them because they have the same base of x, and I do 3 minus 4, and then that'll give me x to the -1. Once you do the subtraction, if the answer is negative, you write it in the denominator. So it's 1 over 4x for the final answer. So on number 9, it just said simplify. So I need to get this to turn positive and this one. So anything that does not have a negative exponent is going to stay in the numerator, and everything that has the negative exponent, I'm moving to the denominator. Now, for the next one, you can either choose to do what I just did and move the negative exponents and make them positive, or you could just use your division rule and just subtract the exponents. So there's 2 ways to do it. So let me show you both ways. I'm going to show you the way that I think is probably easier. Is I'm going to take the exponents because the bases are the same, and I'm just going to subtract them. So I'm going to first work with the x's. So the 3 doesn't have a negative exponent. It'll be in the numerator. And now for the x's, what I'm doing here is -2 minus 4, which gives me x to the -6. Because once I subtract, it's negative, the x to the 6th goes in the denominator. Then I'll do the same thing for the y's. So I have y to the 4th minus -3. Be very careful with these negative exponents when you're subtracting them, because now you're either going to do keep, change, flip, stay, change, change. So it turns into y to the 4 plus 3, which will give you y to the +7. So once you subtracted and got a positive exponent, you write it in the numerator. So this would be your final answer. That's just taking the bases that are the same and subtracting. The other way that you can do it, and again, you can choose, is you can also take the exponents that are negative and move them. So for example, I would take this one, move it to the bottom. Take this one, move it to the top. So if I do it that way first, I'm going to get 3y to the 4th, y to the 3rd, over x squared, x to the 4th. But now I got to go back and use my multiplication rules. And because these two have the same base, I'm going to add those exponents. And that's how I get 3y to the 7th. And then here's same thing, and get x to the 6th. Notice it's the exact same answer. So it's up to you. If you'd rather move the negatives and then use your multiplication or division rules, or just as soon as you see it's a fraction, you could just subtract the ones that have the same base. So here's some more examples. So again, we're going to check to see if the bases are the same, which they are. So here, all I have to do is I'm dividing, so I keep the base the same. I take those exponents and subtract them. 9 minus 7 is 2. And then I'm going to evaluate. 5 to the 2nd power, or 5 squared, and I get 25. On number 12, same thing. They both have the same base. It's a base of x. I'm going to take those exponents I'm going to subtract the numerator exponent from the denominator, and 14 minus 10 gives me 4. So x to the 4th. Now notice number 13, they flipped it. I'm still doing the same thing. I'm doing 10 minus 14, but this time when I do 10 minus 14, I get a negative exponent. Remember, all answers need to be left with positive exponents, so now I need to flip this to the denominator. And that would be your final answer. On number 14, same base. So all we're doing is taking those exponents and subtracting them. And this is where your rules of integers, keep, change, flip it. So this really becomes 7 to the 5 plus 3 power, which will be 7 to the 8th. Now, chances on the quiz of me giving you something this large to multiply without a calculator probably isn't going to happen, okay? It'll be reasonable. So, you might have to do 2 to the 5th power or something like that, but that's not that bad. But 7 to the 8th is getting kind of large. All right, then the next one. Same thing. Now, I could either choose to simplify the coefficients first, and then you could either choose to move the negatives to the opposite spot, but you're still going to have to go back and subtract them. So I could simplify the 15 over 5, and it'll simplify to 3. And then I'm going to take the x, negative 4 minus negative 8, and again, keep, change, flip it, and this will give you x to the 4th. Because after you subtracted, you got a positive exponent, it just gets written as like a whole number. It's not in the fraction. Now, if you would have preferred to flip it and say, well, I want to put the negative 8 to the top and the negative 4 to the bottom, you can do that, but you're still going to have to go back and subtract 8 minus 4, and then you still get x to the 4th, and then you still got to simplify the 15 over 5. Either way, you get the same answer. So it's whatever you're going to be comfortable with when you're working with these negative exponents. Number 16, same scenario. I like to just leave it the way it is and subtract them. But again, you could move this one to the bottom, this one to the top, this one to the bottom, and then use your rules for multiplication and division. But I'm going to go ahead and just subtract them the way they are. Now I'm going to first reduce the 15 over 25. I can divide these both by 5, and it simplifies to 3/5. Then I'm going to work with the a's, because those are the same base. So I'm going to take a to the negative 5 minus negative 2, and this will give me a to the negative 5 plus 2, which gives me a to the negative 3. So that tells me I'm writing the a in the denominator. Then I'm going to do the same thing for the b. I'm going to subtract the negative 1 minus 4. So for the b, negative 1 minus 4 gives me b to the negative 5. And then this tells me that it is also in the denominator, so b to the 5th. So the only thing that was left in the numerator was the 3. And that's just working with the bases and applying that division rule. And it seems like it's a little faster. Now, just to show you, let me rewrite the original problem to show you how you could move it around, but in the long run, you're still going to have to move stuff. So if you choose instead to move this to the bottom, this to the top to make it positive, and then this to the bottom, you're going to end up, and let me simplify the 15 over 25. So I'm going to make that 3/5. And then if I move the a squared to the top, the a to the 5th to the bottom, the negative, and then I put both the b to the 4th and then that green one in the bottom, Now I still got to go back. I still got to subtract these and then add these. So in the long run, I think it's better to do it the way I first showed you. But again, it's totally up to you. So for the a's, if I take a squared and then subtract the 5, I get -3. So then that's going to put that a to the third in the bottom. So I have 3/5, a to the third in the bottom. And then the b's, you're just adding these two because it's multiply. So 4 plus 1 is 5. Same answer I got when I did it that way. Okay, so for this one, again, you can either choose to flip it and make that -2 power positive, or you could simplify what's in the parenthesis first and then apply that negative exponent. Again, you have options. So let me go ahead and I'm going to simplify what's inside first. So I'm going to go ahead and I'm going to take my base A's and then I'm going to take care of my base B's. So right now I'm leaving the -3/4. And then for the A, it's a to the first minus -3. Keep, change, flip it, becomes 1 plus 3. And I get a to the fourth. Because it's positive, I'm writing it in the numerator. Then I'm going to take the b's. B to the first minus the 4 gives me b to the -3. So because it's negative, it's going in the bottom. Now I still have this -2 exponent. Now what I'm going to do is take care of the negative sign. I'm going to flip it to the reciprocal, make the power positive, and now I square everything that's in there. I square the 4, power to the power on the b, I multiply, square the -3, becomes +9, and then power to the power on a to the fourth becomes a to the 8th. And that's your final answer. Now, you could have also flipped it first. You could distribute the 2 to everything. But sometimes I think it's easier if you simplify what's in there and then flip it and apply it. Again, always different multiple ways to do these. So like for number 17, let me rewrite it. Let me go over here to the side. Okay, so -3 AB, 4a to the -3, b to the fourth, -2. All right, let's say instead you want to take care of the negative exponent. So I could flip it to begin with and just keep everything the way it is. Just flip it upside down and now make that exponent of 2 positive. Then I could take care of this negative exponent and move it to the bottom. So 4, and then b to the fourth, and then -3a, a to the +3 because I moved it, and then the b. It's still got the square. Now, these two a's I need to put together. And then I could also subtract these b's. See how this one's going to be a little bit more involved. So here for the b's, b to the fourth minus b to the first gives me b to the third. Then the a's in the bottom become 1 plus 3, so it's a to the fourth. And now I still have the exponent of 2, and now I need to apply and square everything. So 4 squared, 16. This b to the third raised to the second power, multiply it. Same thing here, apply the square to the -3 and to the a to the fourth. And then you get the same answer that I had gotten right here. Do it the same way that I did it the first way. I'm going to simplify what's in the parenthesis first. So the first thing I'm going to simplify is the negative 3 over 9. And I'm going to make that negative 1/3. Then I'm going to look at my base of x. Anything divided by itself is 1, or you think of 1 minus 1 is 0. So the x's are gone. That became a 1. Then there's no y's to subtract, but in order to make that positive, I'm going to just move the y to the bottom, and I'm going to move the z to the top. So the y goes to the bottom, y squared. The z goes to the top. And then now it's still raised to the negative 3 power. And now I can flip to the reciprocal and make that negative 3 positive. So now I have 3y squared over negative z. I don't really need to put the negative 1. And now that negative 3 is positive. And now I have to cube everything in the parenthesis. So I'm going to cube the 3. It becomes 27. The power to the power here gets multiplied. And then the same thing for the z. It's an odd number, so it just becomes negative z to the 3rd. So you can leave it like that. You could also just pull the negative sign in the front, and then the z to the 3rd in the bottom. But leaving it like this is acceptable. And that is it for the negative exponents.